Hi all, I'm Dr. SUJIYA.S, Assistant Professor in the Department of Computer Application at Dr. S.N.S. Rajalakshmi College of Arts and Science. Today the lecture video series 8 I'm going to discuss is about the operating system structure. So the operating system structures are large and complex, and it is common approach in partitioning the task into small components or modules rather than having one monolithic system. And this can be defined with the following structure: the simple structured layered approach, microkernel, modules, and hybrid systems. So simple structure is do not have a very defined structure, and this is simple, small, and limited systems. Examples is MS-DOS. MS-DOS is an interface and levels of functions that have been all well separated. So we have ROM BIOS device drivers, we have MS-DOS device drivers, we have resident system programs, and next we have the application program as mentioned in the diagram. And next is this is the structure of the kernel of the first one. Now we have the kernel interface to the hardware. Next is the system call interface to the kernel, and finally we have the user. So this is the overall diagram of this. And layered approach is the system can make modulars in many ways. One method is the layered approach, in which the operating system is broken into a number of layers. The bottom layer is a zero, which is in hardware that has an highest layer in the user interface, and the operating system layer is an implementations of an abstract objects, makeup of data, and the operations can then be manipulated from those data. The main advantage of this layered approach is its simplicities of constructions and debugging, and these layers are selected so that each user functions or the operations in the services are only from the lower level layers, and each layer is implemented only with the operations provided by the lower level layers, and these layers do not need to know how these operations have been implemented and need to know only what these operations do. And the major difference, the difficulty with the layered approach, it involves appropriately defining the various layers because the layers can use only at the lower level layers. And the problem with the layered implementation is that they tend to be less efficient than the other type. Next is the microkernel layers structure. Is the research is it is being done by the CMU University, developed an operating systems called as MAC that modelize the kernels using the microkernel approach, and this method structures the operating system by removing non-essential components from the kernels and implementing them as a system at the user level program. And this is minimizes the process and memory management in addition to the communication facility. And the main function of this is to provide the communication between the client program and the various service that has been also running in the user space. And the client program and the service needs interactions directly in the microkernel. And one of the benefit is that it makes extending the operating systems very easier. And all new services are added to the user space and consequently do not require modifications of the kernel. So this is one of the advantage of it. And next is the modules. The best current methodology for updating system design involves using loadable kernel modules, and this is a set of core components and linkages and addition services via modules either at the boot time or during the runtime. So the kernel provides core services while other services are implemented dynamically as a kernel is running. And this linking service dynamically is more comfortable than adding new features directly to the kernel, and which would require recompiling the kernel every time as a change made which is being made. And Solaris OS is one of the apt example of this type of structure, and it is being organized around the core kernel with seven types of loadable kernel modules. And this scheduling classes, we have the file systems, we have the loadable system calls, we have the executable formats, and next we have the stream modules, miscellaneous, and devices and bus drivers. So this diagram shows the core Solaris kernel, which includes the scheduling classes. Next we have the file systems. Next we have the loadable system calls, and next we have the executable formats. Next is the steamed modules, and next we have the miscellaneous modules, and next we have the device and bus drivers. So all these has been incorporated for the core Solaris kernel, and this is how the model has been defined. One of the hybrid systems we have is the by the word combinations of different structures resulted with the name called hybrid systems. So it addresses the performance, security, and usability issues in case of hybrid systems. They are monolithic because having the operating systems in a single address space provides very efficient performance. However, they are also modular so that new functionalities can be dynamically added to the kernel. Example, NX and Solaris are monolithic, simple, and also this can be combined as a hybrid system. Thank you.